In this lesson video, we are going to look at physics, one-dimensional motion. We'll be focusing on distance and displacement. This is lesson 101. Let us start. In simple terms, distance is a path traveled, and then displacement is a change in position. So what is important? You should know that distance is a scalar quantity, and then displacement is a vector quantity. Now this simply means that distance, it cannot be negative, it doesn't have direction, it only has magnitude, and then displacement is a vector quantity, it has magnitude and direction. It is possible for it to be negative, and then when we are dealing with displacement, we should consider the direction since it's a vector. Now, looking at practical examples, suppose we have an object traveling to the right 10 meters and then goes back to the left 7 meters. Let us look at the distance. The distance traveled by the object will be the sum of this path taken. So it will be 10 plus 7 meters, which is equals to 17 meters. Now looking at displacement, we need to consider direction. Suppose we say positive, it's the right direction. We consider right direction as positive, and then we consider left direction as negative. So this simply means that our displacement, which is the change in x, or let's simply say x, is equals to, since 10 meters is to the right, then it means we have positive 10, and then plus, we look at the second path taken, which is 7 to the left, it will be negative 7. So all in all, we have 10 minus 7, it's 3 meters. So you can see the difference between displacement and distance. Another example, let's say we have this person traveling from right to left, distance of 20 meters, and then goes back to the right direction 10 meters, and then goes 5 meters again to the left. Now what is the distance covered by the person? Remember, distance, we only take the sum of all the path taken, so it's 20 plus 10 plus 5, which will be 20 plus 10, it's 30, 30 plus 5, it's 35 meters. Now looking at the displacement of the person, remember we take right as positive, then we take left as negative. So the first vector is negative 20, the second vector will be positive 10, the third vector will be negative 5. So x is equals to negative 20 plus 10, it's negative 10. Negative 10 minus 5, we have negative 15 meters. I hope you can see that. Let us look at another example. Remember, you can pause the video and try to work out the question. Play the video to verify your answer. So distance is 10 plus 5 plus 3 plus 8. 10 plus 5 it's 15, 15 plus 3 it's 18, 18 plus 8 it's 26 meters. Now looking at the displacement, we need to consider the signs. Remember, we take right as positive, we take left as negative. So calculating the displacement, it's x. The first vector, which is this one, is to the positive direction. We have positive 10. Then the second one, it's still on the positive direction. We have positive 5. The third one, we have 3, which is on the negative direction. Then the last one is 8, negative 8. So x plus 5 is 15. 15 minus 3 is 12. 12 minus 8, we have 4. So we have positive 4. Now since this answer is positive, so this simply means that our displacement is to the right, because remember, we consider positive as the right direction. That's it for this lesson video. Just make sure you watch the next lesson video based on average velocity and average speed, velocity and speed. That is lesson 102. This is Wahula SJ. Thank you very much.